Okay, welcome. This is actually the very final webinar of the entire class. So hopefully you all enjoyed these webinars and that they helped you learn statistics, because that's what it's all about. And let me tell you the plan today. The plan is, as always, I'll answer any questions that anyone has, and always happy to do that. And then after that, we're going to get into what's called ANOVA. And that is going to be a hypothesis test for something that we haven't dealt with yet. And if you think about it, there aren't that many things, not too many things that you can think of that we haven't dealt with. There's lots that we haven't, but not that maybe you've thought about. And this is one of those. It turns out it's actually a lot more complicated than we're going to be doing today. So that's where, if you want to fully understand ANOVA, you need to get into a upper division statistics class and get into ANOVA. But we'll get into the basics of ANOVA and just kind of how to make it work. We'll also talk about the requirements. There's more requirements than some of the other tests, so we'll go through, and there's kind of a list, and we'll talk about what you need to be able to do ANOVA. And just to let you know, this will probably be maybe the shortest webinar of the entire class, because there's not that much material today. For a bunch of reasons, I try to make the last week the easiest week in terms of material. One is, what big thing is due on Sunday? Yeah, the project. So project 2 is due on Sunday. I recommend getting it done by Saturday, so if something goes wrong, you still have a little extra time. Otherwise, if something goes wrong on Sunday, you're kind of screwed. So it's always better to do it a little ahead of time, and that's a good thing. So it's kind of a lighter week because the project is heavy. So it's a lighter week in terms of the chapter. The material is not hard, but you get the project to do. And then so we'll talk about the project if you have any questions. And then the other thing that that you should be thinking about is this course is over basically a week from tomorrow. So the very last thing that you'll have to do will be the final exam, but it's a lot different than a final exam from a regular course. Final exam for a regular course is usually like 40 or 50% of the grade. This is just 10% of the grade. It's no more than the regular exams, but it's still not nothing. You don't want to ignore it. So that must be done not on a Sunday, like everything else needs to be due on a Sunday, but it must be done within 8 days of now. So a week from tomorrow. So in other words, Wednesday of week 12. And you must have that submitted and turned in finished, I guess, by that Wednesday, because then I make your grades and submit them to the college. So because the class is over. So that's kind of like a final exam. So that's just a big note. And that's pretty much it. Again, this will be a lighter day. I doubt we'll go an hour and a half. See how long we go. Might even be less than an hour. We'll see. Probably less than an hour. So any questions? Any questions? Okay, if there's no questions, then let's get into ANOVA. I want to talk about the things that we've already done and what's left, and that'll be ANOVA. So we have already done, in terms of, when I say things, I mean the hypothesis tests that we've been doing. So we started out with a hypothesis test for a single population mean, and then a single population proportion. So in other words, if the survey question or the data you're collecting are quantitative, then we're talking means. If it's a yes/no question, then we're talking about a proportion. And then we moved on and we said, well, what if we had two means and we wanted to compare them and say, which is bigger? Are they different? Then we talked about a hypothesis test for the difference between two population means. And similarly, we looked at a hypothesis test for the difference between two population proportions, where two yes/no questions, basically, or two groups with the yes/no question is more likely. and comparing. So that was important, and that comes up a lot in terms of the real world. So then after that, after doing the two samples, then we realized that we hadn't dealt with the qualitative survey questions. And that we used the chi-squared tests for. And those were the chi-squared test for goodness of fit, the chi-squared test for homogeneity, and the chi-squared test for independence. So we had those three. And remember, goodness of fit was to see if the distribution of something you don't know about is the same as a distribution you do know, maybe normal or maybe uniform, or maybe some population that you have a census on. So then homogeneity was when, again, you had qualitative, and you want to say if the distribution of this group is the same as the distribution of this group, and you don't know the population distribution for either of them, and you're comparing. And then there was a test for independence, and that's when you had two qualitative survey questions, and you wanted to find out if they were dependent. So if you know about the answer to one of them, does that help you in terms of kind of deciding what the answer might be for the other one? And that's a dependence. And then we did regression analysis. We wanted to find out if we had a measurement of two things that were quantitative, and we wanted to find out if there was a correlation between the two. If one goes up, does the other tend to go up, or maybe tend to go down? And that was a hypothesis test for rho, or for the correlation. So what haven't we talked about yet? So what's left? Yeah, if you have more than two samples, and in particular, if you have more than two samples that are quantitative, right? If you have three types of things, then you can look at those in chi-squared if they're qualitative, but we haven't looked at more than two means. So we want to be able to say, well, are all the means the same, or are at least a couple of them different from each other? Does that make sense? All right, so I'm going to pose something and see if you can tell me what's wrong with it. So I'm going to give you a way of doing it that doesn't work. And that is, let's suppose you wanted to find out if the population mean weight of people in America that live in America differs from state to state. Are they all the same, or are they all, or maybe at least a couple of them are different from each other, right? Maybe California and Nevada don't have the same population mean weight, right? So here's one way of doing it. Okay, let's say level significance is 5%. So what I do is I compare California and Nevada. Okay, take a sample of California, take a sample of Nevada. And if those are different, then at least two are different, right? So then I try Texas and Nebraska. And I do the same thing. I take a sample from Texas, a sample from Nebraska. And if they're different from each other, I say, yeah, at least two are different. So then maybe I take New Jersey and Hawaii and take a sample from each of those and weigh a bunch of people in both states, see if there's a difference in the sample mean weight. Is the p-value small enough using a 5% level significance? And if the p-value is real small, then I say, yeah, there is a difference. And at least two of the states are different. And I can do that for every two different states in America. Okay, I'll be doing it a long time. It'll be thousands of samples, but let's suppose I had time. The computer doesn't really complain about that kind of stuff. And the question is, what's wrong with that? That's actually not correct in terms of you don't get reliable data. What is wrong with that technique? Any ideas? Well, when you say all together, what does it mean all together? Because you could do each pair. What's wrong with doing each pair? Because you want to just see it. Is there a pair that's different? So you check every pair. Because that sounds good, right? You've checked them all. And if a couple of them are different from each other, then you say they're not all the same. There's something really wrong with it. Any ideas? Okay. I usually don't get anyone to come up with the reason why it's wrong, but when I tell you, I think you'll totally understand. Okay, when I do California, Nevada, and if we had a 5% level of significance, and let's suppose that they were all the same, then there'd be a 5% chance I'd have a type 1 error, right? Okay, so then I went and did New Jersey and Michigan, and I have a 5% chance of a type 1 error for that pair. And then I went and did Alaska and North Carolina, and I'd have a 5% for that pair. Well, I'd be doing thousands of pairs, and every time I would have a 5% chance of a type 1 error. So if I did something thousands of times and had a 5% chance every time of having a type 1 error, I'm just about always going to get a type 1 error. Do you see? So doing it pair by pair actually doesn't work. Yeah, it doesn't work because you end up with a huge chance of a type 1 error, even though you set your level of significance of 5% for each case. So what you need to do instead is you need to rely on the math geniuses that came up with a solution. And this class, we are not going to get into the mathematics of it because the math is really tough. But if you really want to get, terrorized by me, ask me in office hours, whatever, I'll torture you and show you the math. And it is brutal, but you better know more than 2 years of calculus. Just let you know that. ANOVA's rough. So instead, you're just going to trust the calculator that it's going to do what it's supposed to do. Any questions on that? And the test we're going to use is called analysis of variance. And the letter, what we usually use an acronym for that. And the acronym we usually use, that everyone uses, is ANOVA. Just to let you know, analysis of variance sounds like you're testing to see if variances are different. That's not what you're testing. The only thing I can tell you is that the variance comes up in the mathematics of working this all out, but I can't get into that because there's a lot of heavy math in it, and it wouldn't be fun for y'all, most of you. So instead, just trust me that there is variance, but it's not what the test is about. The test is about means, and it's a test to see if several means are all equal or are they not all equal to each other. So the way I write the null alternative hypotheses is H naught, you're used to that, colon. Now we're going to have a bunch of means. Mu1 equals mu2 equals mu3 equals mu4. And you just keep going until you're at the last mean that you need to be, and that would be mu whatever it is. So if you were talking about, the example I just gave you, where you want to find out if, if there's any difference from state to state about average weight, then we would have to do 50 of these. It would be a lot of writing. And you typically write ... because nobody wants to write 50 of these things. Okay. Sometimes you only have maybe 3. And that's fine too. It all depends on what you're comparing. It turns out, when I first taught this class, I used to use symbols for H1 also. And what I learned is that no one really understood my symbols or the symbols. So I gave up. And now for H1, we use a sentence. So the sentence is at least 2 of the population means differ from each other. Okay. Notice that's not the same thing as they're all different from each other. Okay. You may think that the opposite of mu1 equals mu2 equals mu3 is mu1 is not equal to mu2 is not equal to mu3, but that's not true. Okay. It turns out that the contradiction to mu1 equals mu2 equals mu3 is you could either have mu1 and mu2 be different, you could have mu2 or mu3 to be different, or mu1 and mu3 but to be different. Maybe a couple of them are the same. So that's why you have to write it this way. At least two of the population means differ from each other. Maybe all the rest of them are the same, but if at least two are different, if exactly two are different, then they're not all the same. Any questions on that? If three were different from each other, then you can grab two of them and say those two are different. So at least two. Do you see? Any questions at all on H0 and H1? Okay. So the good news is, as I promised, this week is probably the easiest week when it comes to the material. So this is all we're going to ever do for this week. It's our last hypothesis test, and this is it. So far, it doesn't look too bad, does it? Yeah, and it won't look bad. The whole thing is kind of nice. So now the requirements. Okay, and I want to give you a warning. Deciding on whether the requirements are met is actually very difficult, but we can't, so we don't do that in this class. So when you leave this class, it does not mean you're going to fully understand these requirements. It just means that at least you have a list to take with you. All right, so the first requirement is all sampling distributions are approximately normal. So in the example I gave, that would mean that the distribution of weight in California is normal, approximately. Distribution of weight in Nevada is approximately normal. The different distribution of weight in Oregon is approximately normal. You'd have to have normality for all of the different ones. Okay. What's one way that you can be guaranteed that you have approximate normality for sampling distributions? This is something that was really important. We had a whole chapter on it. Yeah, and how large is a large enough sample size? Yeah, over 30. So the bad news, by the way, is if you had to do this for my example that was about the state of California, then you would have to have at least 31 Californians, at least 31 Nevadans, at least 31 Oregonians, at least 31 Washington residents, et cetera, you would have to have like over 1,500 in your sample by the time you got through every state. So I do want to give you a heads up on reality that sometimes these could be really tough in terms of practicality. It can be very expensive to hire people to do it. Any questions on that? Okay, so the next one is all population standard deviations are at least approximately equal to each other. And I will let you know that we do not have a test for that, do we? Have we learned a test to find out if the population standard deviations are equal? We haven't. Does that mean there is no test to find out if the population standard deviations are all equal? Yeah, it doesn't mean that. Okay, there is a test, but if you want to find out about it, what do you have to do? Yep, you need to go to a university, not a community college, and you need to take an advanced statistics class, and then you'll learn about testing for multiple standard deviations. We can't do everything in our class. Okay. Okay, so number 3 is we have simple random sampling, or at least approximately simple random sampling. So the main thing is we don't have any severe bias. That actually is a requirement for everything we've done in this entire course. If you have bias, then your data is completely worthless, right? If you have bad bias. So that's nothing new. You can't do anything with that if you have a whole lot of bias. You're not going to be able to do any hypothesis test or confidence intervals or looking at a chart and like believing it. If there's bias, don't trust it. If it's very minor bias, it's all right. But if there's big bias, definitely don't trust it. Any questions on that? Okay, even though you can usually almost never do simple random sampling, what you can do is you can reduce bias do you remember maybe in the first week of class we talked about it? What's some ways of reducing bias that's practical in most cases? Yeah, you could do stratified sampling, you could do representative cluster sampling, right? You could do systematic sampling. So there are different ways of reducing bias, and we talked about those in chapter 2, first week of class. Okay, then the next is the samples are independent from each other. So my example of surveying maybe 31 people from every state and asking them how much they weigh, that would be completely independent if you just grabbed a bunch of people in each state and they had nothing to do with each other. So the main issue on this independence is what you can't do with ANOVA is, let's say you asked 35 people 3 different survey questions that were, all comparable and quantitative. Then you can't do ANOVA on that because those would be dependent. Because if you're asking the same survey questions to each individual, then that's dependent. Any questions on that idea? Does that mean that there are no statistical tests for dependent data for more than 2? No, it doesn't mean that. There's a statistical test for anything, but basically. So just let you know, again, you got to take another stats class. So one of the things today is to convince you that there are reasons to take more stats. Okay, you may have to take it if, for example, you are planning on getting a master's degree or a PhD. Then most graduate degrees require more advanced stats than elementary stats, because you're going to be using it deeply. So that's just a note, is that those are usually the people that take more advanced, or nerdy people like me, because I teach it. So I took a whole lot of stats classes, all kinds of proof stuff, but other stuff too. And then the final one is the samples were consistently taken. Okay, so what that means is, let's suppose that you wanted to do this idea of finding out if there's a difference in weight based on state. Then you're not going to do it yourself. No one has time to do that. Not only that, you'd have to travel all over the place. So in the real world, what would you do? Yeah, you get a team. You would maybe find an individual, a worker, possibly from every state in America. So you get a team of 50 people. And then you would make sure that everyone in that team asks over 30 people in their state. Do you see how that works? So one of the things you have to make sure of is that the survey question and maybe the way you collect the data is the same for every team member. Does that make sense? Yeah, so you can't really have different ways of collecting the data if you have a bunch of different people doing it. So, for each of the different groups. Okay, and I'll let you know, I think I mentioned that was one of my first jobs, right? I remember how old I was? I was 11 years old. Yeah, actually, it was late 11 or 12. It was summer of my 11 and 12. I think I was 11 and then I turned 12 a month later. And what we would do, I was one of the team members, is we would meet. Okay, I tell you for sure, that I did not meet on Zoom. That should be really obvious to you because it was a long time ago. So we would meet in a room, and then the boss would tell us how to conduct the survey, what the survey questions should be, and all the different reactions we need to have for surveying. Okay, and then that's done right, and that's how you do it right. So I've experienced it on the other side of actually conducting the survey instead of teaching it or something. So you just got to make sure it's consistently done. Any questions at all about the requirements? Any questions? Okay, I will let you know number 2 is not one that you'll be able to do by the end of this quarter, or not be able to understand how to determine if they're all the same or not. So that's one of those that, you do a little more stats. You do some reading up on it or take another class. The rest of them, we've talked about all of them, actually. Any questions at all about all the requirements? Okay, so this is done a lot. So let me give you an example, which I made up, by the way. Okay, so suppose a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay, so for example, I live 2 miles from the nearest public library, if you don't call the college a public library. I mean, kind of regular old public libraries. Okay, so that would be my answer. And you notice if I asked you all how many miles you live from the nearest public library, what would you say? Okay, 2 also. So the point is everybody, okay, if they did the research, would answer with a number. Okay, that's the important thing. So this is quantitative. Any questions on that? And we want to look at races. We want to look at racial differences. So I looked at, I just wrote down white, Black, Hispanic, and others. And then I wrote down what you can imagine would be the results of the study. By the way, is this a study that you would rely on, taking a look at it? Yeah, no, this is a completely ridiculous study. So I want to give you a big heads up. In class is a lot different than the real world, because in class, if I did, what's the problem if I gave you one that was reliable? Yeah, you would have to sit there typing all day long. And that's one of the things you got to do in the real world. You have to type all day long. Okay. Nowadays, you might be able to scan it in and have a computer put it in a spreadsheet. It might be possible now. I haven't tried that, but I bet you can do that. But the point is it would be messy. So I want to give you a heads up that this example is not a good real life example, because we have a sample size of 4 for Blacks and others, and that is so way too small. It's way, way too small. Okay. So what assumptions must we make in order to perform the ANOVA test? And the key on this is look to see if those assumptions are needed for this study. So the first is, do we have to assume normality? What do you think? Absolutely. All the sample sizes are too small. So you would have to assume that the distribution of library distances for whites is normal. The distribution for library distances for Blacks is normal. The distribution of library distance for Hispanic is normal. And the distribution of library distances for other races is normal. Okay. Just to let you know, let's suppose that, it looked like this, but let's suppose that, I don't know, we just had a good day and we surveyed 40 Hispanics, but we only did 6 whites, 4 Blacks, and 4 others. So that would be 54 total. So if we had 54 total, would we have to assume the distributions are normal? So the answer is yes, yes, no, and yes. Not yes, 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 and yes. So we would have to assume white distribution was normal, Black distribution normal, but we wouldn't have to assume that the Hispanic distribution was normal if the Hispanic had 40 in the list, and we would have to do for the other. Does that make sense? Yeah, so this really depends, it doesn't mean every single one has to be assumed normal, just the ones that have too small a sample size. In this case, all of them, but that won't always be true. Okay, do we have to assume that population standard deviations are all equal? Absolutely for this class, because I haven't told you how to decide if they are or not, then you just have to assume it. Sound good? Okay, how about simple random sampling, no bias? We have to assume that. We do because it didn't tell us about the study. Okay, there's a chance that you may not have to assume it if you knew more about the study. But it's still hard to not have bias. By avoiding bias is really tough. How about the samples are all independent? So if you look at this, there were 5 things. Do you have to assume the samples were independent? Okay, the answer is probably not. Nothing was told. So in a way you do, but in the real world, this kind of study would almost certainly be independent. Because we're not asking like one person 4 questions. Does that make sense? We're not looking at a family and asking the members of the family and then another family and the members of that family. These are just a bunch of people all over the place. Do you see what I mean? So this is one that there's a good chance you wouldn't have to assume the distribution. I mean, the sampling was done independently, because it probably was, because this is the kind of study that would be done independently. Do you see? Okay, and then do you have to assume that the sampling was all done in the same manner? So the way I worded over here was the samples were consistently taken. Okay, so nothing was said, but probably in the real world, you wouldn't need to assume that. I doubt that asking a white person would be any different than asking a black person. How far are you from the library? Does that make sense? So unless you hired a bunch of racist people or something, hopefully you would never do that. And you can be asking it from the same way. So that's probably not an issue. Do you see that? These aren't 100% yes, no questions because there's reasoning behind it. So there's a most likely this was done, all collected in the same manner, okay, or consistently taken, because this is the kind of study that would be. Okay, unless again, you hired some racist person. Any questions at all on getting the assumptions for this ANOVA? Okay, so next we write down H naught and H1. So H naught is going to be the population mean distance that white people live from the nearest public library is equal to the population mean distance that Black people live from the nearest public library is equal to the population mean distance that Hispanic people live from the nearest public library is equal to the population mean distance that other races live from the nearest public library. Or in other words, mu sub W equals mu sub B equals mu sub H equals mu sub O. Any questions at all on H naught? See how that works? Once you know to use ANOVA, it's usually not that hard. Okay, and then H1 is at least 2 races have different population mean distances from the nearest public library. Okay, maybe Blacks and Hispanics are the same distance, but maybe whites and Hispanics are different. Do you see? And that would satisfy H1. Maybe they're all different. Maybe whites and blacks are the same, Hispanics and other races are the same, but those 2 pairs are different from each other. That could happen. And that would be different also. Any questions? Any confusion? Was my promise right that this isn't too terrible? Okay, and it's not going to get any worse, just to let you know. Okay, the name of the test, which I will ask you, is what? What's the name of the test we're using? Yeah, ANOVA, all capitalized, is the name of the test. Any questions on that? Okay. The level of significance. How are we going to get the level of significance? What do you think it would be for this? Yeah, this is a sociology question, and sociologists almost always use 5%, so 0.05. Any questions on that? So that would be the standard level of significance, and I can't imagine using anything different than that. How do you think we're going to get the test statistic? Yeah, so let's go to the calculator. Should be really easy. What calculator do you think we need to use? Yeah, the last one. This is the very last day, last webinar of the entire class. And I told you we only have one topic today. So we're at the end. So this is like a celebration mode because this is it. Hopefully you can read 1 through 25 and now understand them all. Is that pretty cool? When we first did this, you probably got really scared. And hopefully if you're all keeping up with the class, then it's not so scary anymore. Tiring maybe, but not scared. Okay, so if I click on ANOVA, which is number 25, then the way I asked it is enter the data values separated by commas. For example, 3, 4, 7, 9, -2, 8. Then hit calculate, and the F statistic and the P value will be generated for you. I do want to mention something is that we've had a lot of different distributions in our class. I don't know if you remember. See if you can remember some of them. What distributions have we learned? A whole bunch of different types of distributions. We had names for them. Yeah, normal, uniform, students T. I'll give you some more binomial. Remember that one happened? Then we had the chi-squared distribution. And now we have what's called the F distribution. So again, the math is too hard to explain why. It's a different distribution than what we've had before, but you can trust me, hopefully. And it's called the F distribution. And what we have to do is just put in the data. So I'm going to go back to my data. And I wonder if this works. I'm going to try copy and paste and see if it'll copy and paste in. Yeah, it did. What do you know? So 15, 4, 11, 9, 3, 2. And the next one was 12166. You do have to put the commas in. So 12, 1, 6, 6. And then the next one is 9, 17, 5, 14, 7, 1. Copy that. I can paste. Put the commas in. And then the final one was 18, 11, 2, 8. And I hit calculate. And the test statistic is F is about 0.33. And the p-value was about 0.8. Yeah, so about 0.8. Any questions on that? Okay, and the good news is you write the conclusion. It's not going to be anything surprising. hopefully, you know, if the p-value is 0.8, what do you do for a conclusion when the p-value is 0.8 and the level of significance is 0.05? Yeah, you fail to reject. And what are the first few words in the conclusion? Yeah, there is statistically insignificant evidence. And then you could just, if you want, you could just write down the alternative hypothesis. So there is statistically insignificant evidence to make a conclusion that at least two of the races have different population mean distances from the nearest public library. I do want to mention, because you see this a lot in the real world in terms of publications, they will often say it's slightly different, and they'll say there's statistically insignificant evidence to make a conclusion that race is a factor in the distance from the nearest public library. You'll often see that. That's used a lot in publications. So don't be surprised if you read that for ANOVA, because you'll hear about race being a factor. It means exactly the same thing. Any questions? Any questions about kind of this idea? Okay, I will tell you something, some good news is that every one of these is basically looks like every other one of these. So it's always the same process. I don't need to go through a second example because I mean, they're not all about race in public library, but the step-by-step process is just your standard hypothesis testing. You write down the null hypothesis that mu1 equals mu2 equals mu3, and you keep going until you're done. And you write down the alternative hypothesis, at least two of the population means differ. Okay. And then you use ANOVA, go to the ANOVA calculator, you put in your data, click calculate, find your F statistic and your F value, your test statistic, and your p-value. Look at the p-value. If it's less than typically 0.05, then you say there is statistically significant evidence. And then to make the conclusion that, you just copy and paste to H1. And if the p-value is greater than 0.05, then you say there is statistically insignificant evidence to make a conclusion that, and then you copy and paste your H1. Okay, or write this whole factor idea. Any questions? Any questions about this idea? Any questions? Doesn't look too bad? Okay. I will give you a heads up, and it's not for this class, but for if you're ever doing research, doing advanced stuff, there's something called two-way ANOVA that we don't do in our class. And that's when you have another variable, it turns out. I'm not going to get into the details because we don't do it in our class. But just in case you're reading a publication article or something, and you see something that looks really different, there's a good chance it's two-way ANOVA. And there's actually multi-way ANOVA too. There's like 3- and 4-way ANOVA. So just because you see the word ANOVA does not mean it's exactly what we're doing, because there's more advanced ANOVA. And that's all I can say. Can't get into the details because you probably don't want to see them. But I do want to let you know there's definitely more to ANOVA than what we're doing. We're just doing the basics of ANOVA, which is one-way ANOVA, they often call it. Any questions? Okay, so my promise was that this was going to be a shorter webinar. Do you remember? So what do you think I got to do now? Yeah, the secret word. This is our last secret word of the day. And I just want to, before I tell you the secret word, I just want to thank you for coming. And for those watching it, those of you watching this on YouTube, thank you for watching this and being polite in your conversations to each other. And the secret word is thank you. Because I want to thank you all for doing your best for this whole quarter and hopefully getting through the stats class and working hard and learning about statistics and being professional about it. So the secret word is thank you. So that's something to remember. I do want to mention, since this is the very last time I'm going to officially give you any webinar conversation. Just because the class is over next week doesn't mean that I'm like disappearing into the universe and you can't ever get in touch with me again. If you're ever in an upper division class or something and you have some stats questions, I'd be happy to answer them. Just drop me an email and I'll help you out and I'll work with you and, make sure that you understand. It'll often be something that we haven't learned in class. Sometimes so you forgot because it had been a couple of years or something. But I'm always happy to help you out with whatever you need. If you need to do statistics for your business, I'll help you, but there's a catch. And you know what the catch is? If it's for business instead of being a student? Okay, there's a charge. And here's what I do. Okay, I don't want the money. If I help you for your business, and I've done this for a few businesses already, I want you to donate to our foundation to a scholarship. And I'll be happy to do that. I won't charge, but I want you to donate what you feel is comfortable for you. And your business will get a tax deduction and all that too. So that's my rule about helping. If it's for being a college student, that's different. But if it's for your business, then you should be able to help support the college for Lake Tahoe Community College students. And that's my one rule if it's for your business. Any questions at all? Okay, well, what I'm going to do then, I'm going to stop the video. I want to thank you all again for this is our last webinar. I will be checking the Q&A forum this weekend. I'm going to be at a conference, so I'm not going to be checking as often as usual. And the project forum. I won't Friday, Saturday, Sunday. I'm going to be mostly traveling and at the conference. I'm actually speaking at it. I'm the tech person for the conference. I'm in charge of technology. So I'll be pretty busy. So just let you know, but Thursday I'll be able to answer lots of questions if you have any questions. Also, I will not have my office hours on Friday because I'm going to be traveling to the conference Friday. But I will have office hours today and Wednesday and Thursday, and happy to help you out. And pop in questions into the forums or email, whatever. So I think I'm going to stop the recording.